Definition of volumetric displays. A volumetric display device is a graphic display device that forms a visual representation of an object in three physical dimensions, as opposed to the planar image of traditional screens that simulate depth through several different visual effects. One definition offered by pioneers in the field is that volumetric displays create 3D imagery via the emission, scattering, or relaying of illumination from well-defined regions in space. A true volumetric display renders a digital representation of a real object in a physical space. The resulting image displays similar characteristics to a real-world object, enabling an observer to view it from any direction, focus a camera on a specific detail, and see perspective, meaning parts of the image closer to the viewer will appear bigger than parts that are further away. Security checks and border crossings. By fully capturing the 3D capability of X-ray imagery, border and customs inspectors can more effectively scan and observe the interiors of vehicles, trucks, shipping containers, and packages. True 3D displays offer officials multiple perspectives to resolve ambiguity. TSA screeners would gain a clearer view of the objects in your suitcase, potentially reducing additional screenings of suspect luggage. Air traffic control. Several recent near crashes between airplanes have raised scrutiny over air traffic control systems. Current systems display the position of airplanes as icons on a flat 2D display. With 3D volumetric displays, however, operators would have a more comprehensive overview of the airspace and planes' location in relation to one another and better navigate them to and from runways. Natural disasters. The federal government undertakes geospatial exploration in which it collects, maintains, and uses information linked to geographic locations to help in decision-making and to support national security, law enforcement, healthcare, environmental protection, and natural resources conservation, among other functions. 3D volumetric displays would offer more information for geospatial analysis that could improve road maintenance and natural disaster responses. Oil and gas exploration. Seismic data is critical in assessing an area for potential oil and gas extraction. However, seismic data suffers because 3D data is still underutilized by 2D displays. 3D volumetric displays, by offering a detailed, 3D depiction of where deposits might lie, how large they are, and how accessible they might be, can make the expensive process of oil and gas exploration more efficient, accurate, and productive. Healthcare. 3D volumetric displays can provide volume rendering of the surface and the interior of any human organ, increasing the effectiveness of real-time imaging systems for doctors and surgeons who need better awareness of what's happening inside the human body. For now, these innovative 3D volumetric displays are still in the early development phase but could be boosted by government funding. The US government's Small Business Innovation Research Fund fuels just this kind of advancement, and Scott Defense and 3D Icon are pursuing funding from the full spectrum of interested agencies, from the Defense Advanced Research Projects Agency to the National Institutes of Health. Homeland Security. The most commonly observed role of Homeland Security is at airports, where agents screen millions of passengers each year for potential threats before they board planes. Homeland Security also monitors passengers using other forms of transportation, screens millions of cargo containers transported by air, ground and sea each day, monitors the borders by land, sea, and air, monitors critical infrastructure, and coordinates a federal response to domestic disasters. Defense simulation and training. In military operations, a commander must always maintain a perspective of the battlefield. Planning for combat operations and analysis of the mission, terrain, enemy, and weather must all be considered prior to committing forces, and once deployed, these same data must be continually monitored. The capabilities of the military in acquiring and delivering timely information from highly dynamic and uncertain environments to the command level is rapidly outpacing their ability to create a visual representation of these combined data for situational awareness across land, sea, space, and cyber. Swept volume display. Swept surface volumetric 3D displays rely on the human persistence of vision to fuse a series of slices of the 3D object into a single 3D image. A variety of swept volume displays have been created. For example, the 3D scene is computationally decomposed into a series of slices, which can be rectangular, disc-shaped, or helically cross-sectioned, whereupon they are projected onto or from a display surface undergoing motion. The image on the 2D surface changes as the surface moves or rotates. Due to the persistence of vision, humans perceive a continuous volume of light. The display surface can be reflective, transmissive, or a combination of both. Static volume. So-called static volume volumetric 3D displays create imagery without any macroscopic moving parts in the image volume. It is unclear whether the rest of the system must remain stationary for membership in this display class to be viable. This is probably the most direct form of volumetric display. In the simplest case, an addressable volume of space is created out of active elements that are transparent in the off state but are either opaque or luminous in the on state. When the elements are activated, they show a solid pattern within the space of the display. Several static volume volumetric 3D displays use laser light to encourage visible radiation in a solid, liquid, or gas. Illustrative example. These are some of the companies offering solutions and offerings for volumetric displays. 3D Icon, Felix 3D, Holographica, Holoverse, Lightspace Technologies, Looking Glass, Vox, Zebra Imaging.